Okay, welcome. We are going to be talking about 1.4, equations of lines and modeling those lines. So far we've encountered the standard format where we have ax plus by equals c. We know that a, b, and c are constants and that all three, a, b, and c, cannot all be 0. We also know about the slope-intercept form. We've talked a fair amount about that. Y equals mx plus b, where m is our slope and b is our y-intercept. Today we're going to talk about point-slope format, which is a y minus y1 equals m times the quantity of x minus x1. So we're going to start with the equation for slope. This is a pretty straightforward. We've talked about this to some significant degree. So we have y2 minus y1. All of that is being divided by the quantity of x2 minus x1. So that's our equation for slope. We want to multiply to get rid of the fractional piece. So we're going to get rid of the x2 minus x1. And so we wind up with y2 minus y1 equals slope times the quantity of x2 minus x1. Now, we're going to want the generalized form of the equation of the line. This will give us a specific value. We don't want specifics, we want a generalized form. So what we're going to do is we're going to make this, instead of a value, we're going to make it a variable. And this, instead of a value, we're turning it into a variable. So we're going to have y minus y1 equals m times the quantity of x minus x1. All right, and this is a very useful format when you have the slope and a single point. It may even be easier than finding the slope-intercept format. So both of those are commonly used. We know the slope at least one point, or we can use 2 points to calculate slope. We can use either of these equations on the line. So given a slope of 7 and the points of 2, 3, and 1, negative 4, we can easily solve. So keeping in mind that it doesn't matter which point we pick in order to plug into our point slope format, we can do either y minus 3 equals 7 times the quantity of x minus 2, or you could say y minus the negative 4 or y plus 4 equals 7 times the quantity of x minus 1. Both of those are acceptable versions of the point slope form. If we want to get our format into slope intercept form, we have a little bit more work to do. So we're told we're using our points, right? Here's my y from the 2, 3, and here's my 2. So there's my x value, there's my y value. I have 3 equals 7 times 2 plus b. I could also use negative 4 equals 7 times 1 plus b. When we go ahead and we solve for b, we get negative 11. So our equation of the line is going to be y equals 7x minus 11. Now, that gives us a bird's eye view. Looking at parallel lines, we know that parallel lines are denoted by 2 lines next to each other like this. And the way I remember which one is which, parallel lines versus perpendicular, is the parallel lines has the parallel symbol inside of it. Now I realize that that may only be for English, but it's helpful to at least have something to use as a mnemonic. Okay? So they have the same slope and they must have different y-intercepts. Okay? If it's the same y-intercept and it's the same slope, it's just the same line. It isn't, there is nothing different about it. So if they're not parallel, it's the same line. So in this case, I'm going to say, oops, let's do this. We have a y is going to equal 3x plus 10, and our y equals 3x minus 10. Now, they do not have the same intercept. They have the same slope. So these 2 lines are going to be parallel. They will never touch in the geometry that we will use. It is possible to kind of mislead people. So if I were to say y equals 9 over 3x, right, that doesn't look like a 3, but when you reduce it, it becomes a 3. So just because it doesn't look exactly like a 3 or exactly like some slope, don't discount it until you've kind of worked it through and made certain that the slopes are not in fact the same. All right, so perpendicular lines. Perpendicular, we have the lines are going to meet at 90-degree angles. Okay, so they meet at 90 degrees. All right. Perpendicular lines have the slopes that are reciprocal of each other and opposing signs. So a way to super quick test whether or not something is a perpendicular line, you're going to take your slope from the first line and your slope from your second line, multiply them together. If you get a -1, you actually have a perpendicular line. So if I were to say y equals 5x plus 10. If you take a look here, remember that 5 is really a 5 over 1. All right. So in this case, my perpendicular line here is going to be y equals -1/5, right? It has to be the opposite sign, and it's the reciprocal. And I don't have to have any kind of y-intercept specific. It can be the same one or it can be different. In this case, I'm going to call it the same. So they're going to both pass through 0, 10, and they're going to, that's the point where they will form 90-degree angles. Okay. If we already have a fraction, right? If we already have a fraction and we say it's -3/7 x, and I want the line that's perpendicular to that. All right, I'm going to say y equals 7 over 3, and since this is negative, I want the opposite of negative, which is positive. So here is my perpendicular line, right? So 7 over 3x plus 3, because this is a -3/7 x, okay? And in each of those cases, if I were to take 5 over 1 and I multiply that by 1 over 5, that's a negative. When I go ahead and cancel those out, I wind up with a -1. Same process here. If I start with a -3/7 and I multiply that by 7 over 3, again, I'm going to wind up with a -1 is my solution. All right, that's it.